Hi everyone, my name is Mesa and I'm one of the design programming tutors. Today we're going to build on top of the basics we learnt last week and delve into making patterns with code using conditionals and for loops. These coding concepts might seem a bit daunting right now, but are honestly going to make your life a lot easier going forward. So let's get started. Today we'll be covering if statements, for loops, and nested for loops. Specifically, I'll be running through the required challenges of this week, but we do highly encourage you to attempt the recommended challenges in the time before next week's class to further cement your knowledge of conditionals. Just a couple of things to note before we get started. Number one, your first milestone challenge is coming up next week, which is your first assignment. The challenge is already available in this week's content under the name Procedural Composition, but this isn't due until next week, March 17th. Hopefully by the end of today's tutorial, you'll feel comfortable with some of the key coding concepts needed to get started. The second thing I wanted to mention is that the recreating an existing design challenge is slightly more difficult and is considered an extension challenge. Feel free to leave it for this week if you're not feeling confident just yet, but I definitely recommend you come back to it sometime before the in-class quiz. With that out of the way, let's have a brief refresher on what conditionals are. If statements are the main type of conditional we will use in this unit. It's essentially a test that is run by a computer that can make decisions about your program. These tests return Boolean values, meaning either true or false. We can write different segments of code that can be executed if a test results in either true or false. If statements require a test to run, these tests involve operators of some sort. Relational operators, which you might be familiar with from mathematics, are used to compare two values and therefore determine a relation between them. For example, one value might be greater than another. Logical operators can be used in a more complex way to combine two or more expressions. This can result in creating tests that must meet multiple criteria before a segment of code can be run. You'll become super familiar with operators as we'll use them all the time in our if statements. But to break down the syntax of an if statement, first of all, we must have an initial test with an operator. Following this, in what I like to call swirly brackets, is the segment of code that will be executed if the test is true. The final part of the if statement is the else conditional. This is an optional element that you can add with the following block of code that will run if the initial test is false. Now that we have a good understanding of conditionals and if statements, let's have a look at the first challenge, Introduction to Conditionals. This part of the challenge is asking us to draw circles when our mouse is on the left-hand side of the canvas and squares when it's on the right. We've been provided with quite a bit of code. As you can see, there's a scaffold of an if statement right here. I'm just going to copy all of this code and paste it into the p5.js web editor. It's just my personal preference. I like to see the code and sketch right next to each other, but you can definitely just follow along on the CCC platform. So I'm just going to copy and paste it here and run it. So as you can see, nothing really is happening when I move my mouse around, but there is a line being drawn down the middle of the canvas at width divided by 2. It's going from the top of the canvas to the very bottom. We can definitely use this line as a hint to where our middle point for the if statement should be. At the moment, the if statement is saying if mouse X is less than 100 pixels, which is quite a small segment on the left-hand side of the screen, so it's definitely not very wide. Our first step would be to fix that and make it width divided by 2. So we're testing if the mouse is anywhere between the left edge and the middle of the screen. Next, we're going to have to put in a statement of what we want to happen if this statement is true. We want to draw an ellipse at mouse X, mouse Y, because we want the ellipse to follow my mouse around. And I'm just going to give it 125 for its width and height. Let's run this and see what happens. Okay, on the left-hand side of the screen, it's drawing ellipses like we want it to, but on the right-hand side, nothing's being drawn just yet. So let's pop in some code to say what we want the program to do if mouse X is not less than width divided by 2 and is therefore greater than width divided by 2. I'm going to use the rect function and give it 125 for consistency's sake. And let's run this code. Awesome. That's working exactly like it should be, and that's this part done. Take the next 10 minutes to play around with the code from part 1 to try and achieve something similar to the pattern in part 2. Think about how you can use logical operators to make one if statement run 2 tests. I'll run through part 2 in detail with you once 10 minutes are over. Part 2 of this challenge is taking what we just did in part 1 to the next level. Instead of creating 2 conditions, we now need to create 4 conditions for each quadrant of the canvas. There are a few different ways to go about this, but I'm going to approach this by doing 4 different if statements. The blurb here gives us an indication that we'll need to use logical operators to make sure that each test we do meets 2 criteria, one for the x-axis and one for the y-axis. So to start off, I'm just going to copy and paste this code into the p5.js editor. And run it to see what we're working with. So there's no interaction just yet, but there are red lines that show the boundaries of the quadrants, which should also come in handy with our if statements if we get a bit lost. Let's start with the top left quadrant where we want to draw our circles. We know that it's going to be on the left-hand side of the canvas like it was in part 1, so let's just do what we did then. Mouse X is less than width divided by 2. We need to put in what we want to happen if that statement is true. And then I'm going to run it and see what happens. Right, this looks exactly like part 1 did, but our next step is to add another condition that relates to the y-axis so that the circles are only drawn in the top part vertically as well. This red line here is at height divided by 2, so let's give that a go. We have to add a logical operator here to make sure that both these criteria are met. Mouse y less than height divided by 2. And another key thing to remember here is to make sure each condition has its own brackets. So think back to basic mathematics and the order of operations. You want to make sure it's all segmented so there's no room for error. Let's try this code. And magically we've got it in the top left corner. So now we have to repeat this process for the other 3 quadrants. I'm going to cheat a little bit and copy and paste the code and just change the values. But before I do that, I'm going to clean up my code a little bit. I'm going to get rid of the else part of this statement since I'm going to be approaching this by doing 4 different if statements. So we don't really need that. I'm also going to get rid of these comments and instead put a comment that relates to what I am actually drawing to canvas. So top left quadrant circles. So if I look at my code, I can easily understand what it is this piece of code does. Now I can just copy and paste this little segment of code and start on the top right quadrant. At this point, if you're feeling confident, feel free to tune me out and try and tackle the rest by yourself. But for those of you who want to follow along, that's completely fine because I'm going to walk through the rest of it now. Since we're doing the right quadrant, we've got to change around our relational operator. Now we're looking for mouse X to be greater than width divided by 2 because we're dealing with the right hand side of the canvas, which is between the middle point and anything to the right of it. The second part of this test is going to stay the same because we still want to be in the top half of the canvas, but instead of an ellipse we want to draw a square. So I'm going to write rect here instead and give this a shot. That's working great. Let's just work our way clockwise. I'm just going to do the bottom right quadrant now, and that's going to be a circle. So if mouse X is greater than width divided by 2 is going to stay the same because it's still on the right hand side of the canvas. But mouse Y is going to change because we don't want it to be in the top half of the canvas anymore. We now want it to be in the bottom half. And this is where it's really important to remember that the origin is in the top left corner, and the further down you go, the larger Y is. So we want mouse Y to be greater than height divided by 2. And we'll do our ellipse and the rest should stay the same. And let's just do our final one. We want mouse X to be on the left-hand side of the canvas, so we'll make that less than width divided by 2. And the Y values will stay the same since it's in the bottom half of the canvas. Change it to rect, and let's try this all together. That should be it. That's working really great. As I mentioned before, there are a few different ways to approach this part of the challenge, but I think for now, this is probably the simplest and easiest to understand. Now you can add styles to make it more unique. This is just an extension to the challenge, but you can play around with the stroke and the fill to make it more customized. For loops are an extremely efficient way to write iterative code in a few lines. For loops also involve tests, which, if successful, will run a block of code a specific amount of times. You'll become very familiar with the layout of for loops, but generally they're made up of 4 key parts. Number 1 is a variable. This must be declared at the beginning of the for loop, as this will be assigned different values as the for loop runs. In this example, the variable is named I and has been given a value of 50. Number 2 is the initial test. The code will run the variable through the test to determine if the loop and following code should run. Number 3 is a segment of code that will be executed each time the for loop runs. In this example, the first time the for loop is run, I is equal to 50. The for loop will then test to see if I is less than or equal to 500. Seeing as that is true and 50 is less than 500, the ellipse will be drawn to screen. Number 4 is the update to the variable value after the code has been executed. After the ellipse is drawn to screen, I is then increased by 50 and in the second loop now equals 100. The code will then check if I still passes the test and is less than or equal to 500 and will loop until the test becomes false and the value of I is greater than 500. Overall, the key to writing a for loop is to identify patterns in your code and figure out what is staying the same and what is changing. Let's run through step 1 of Introduction to For Loops to get a better understanding of for loops in practice. Having a look at this code from step 1, there seems to be a lot of repeated bits of code. We can use for loops to achieve the same result, but in a much more concise way. The key to creating a for loop is to identify which values you want to change and which values you want to stay the same. We want to take the changing values, in this case the value being added onto mouse X, and put that into the for loop. Following the typical structure, it would look something like this. For let X, I'm going to use X because it's the amount being added onto the X position, equals 0. X is less than or equal to 200. X plus or equal 50. Now to break down what I've just done, I've set up a for loop that starts at 0, which will increment by 50 each time it's run, while the statement X is less than or equal to 200 is still true. So 200 is the max value of X, and the for loop will continue to add 50 onto the value of X until it hits 200. Once it hits 200, this for loop will stop running. Now we want to put in whatever is left over and has stayed consistent into the swirly brackets. I'm going to add on X instead of a numerical value because that's what's incrementing now. Mouse Y and 50 stay the same. And I'm just going to comment out these lines of code using Command / on a Mac and Control / on a Windows. And as you can see, that runs exactly the same. And instead of using 1, 2, 3, 4, 5 lines of code, we're using 2 lines of code. And now this is much more versatile as well. So if you want to add on smaller increments, for example, as you can see, the circles are much closer together now. Or if you want to make the max larger, you should be able to fit in more circles now. And now it just becomes super easy to change things, and it's a much more efficient way to write out your code. For the second challenge, it's important to note that for loops can not only be used to increment values, but can also be used to decrease values. This can be applied to the position, size, and color of elements being drawn to screen. Try and identify which values are changing and create a for loop based on that. A hint for this challenge would be to use the mapping function to evenly distribute the color change across all the squares. Keeping everything you know about for loops in mind, try and solve steps 2 and 3 for the next 30 minutes. Your tutor is in the room to answer any questions you may have, and I will run through my approach to step 3 after you've had a go. So this challenge is basically asking us to use 4 different for loops to recreate the pattern. In the top left and bottom right quadrants, we have vertical lines, and in the other two, we have horizontal lines. It's also asked us to use relative values so that it scales nicely to different screen sizes, which we can definitely do. If this gets difficult to visualize at any point, I would recommend sketching it out on a piece of paper to get a better idea of the coordinates and relationships between points. So let's get started. As we're moving from the left-hand side to the middle, the lines are incrementing on the x-axis, but are staying the same on the y-axis. The first y positions start at the very top of the canvas, and the second y positions are at the height divided by 2, which is halfway down the canvas. So let's put this into code. For let x equals 0, x is less than or equal to width divided by 2, x plus or equals, I'm just going to say 10 for now. It might need to be a bit bigger, it might need to be a bit smaller, I'm not sure, but we'll see what the final output looks like and change that if need be. And the final thing we need to write out is what code we want to run each time this loops. So we wanted to draw a line each time it loops from x0 to x height divided by 2. Let's run this. That looks pretty good. Let's scale it as well to see if it works. Yep, that works great. I'm just going to increase this increment to 15 just because I think it'll look a bit better. Yeah, that's great. Now let's move to the top right quadrant where the lines are horizontal going from the middle of the canvas, width divided by 2, to the rightmost end, width. The y values are incrementing as we go down the y-axis, so this will be used in our for loop. Let's look at the code. For let y equals 0, y is less than or equal to height divided by 2, y plus equals 15. I'm just going to put the same increment so it looks consistent, but now for our line, width divided by 2, y width, because it's going all the way to the right end of the canvas, and y. So the y values are increasing each time it loops, and the x values are going from the width divided by 2 to width for each line. Now we have to go do something similar for the bottom two. The bottom left quadrant also has horizontal lines, so the y values are also changing and the x values are still staying the same. But overall, the starting and ending points will be different. The x values are staying the same, but this time they're starting at 0 and going to width divided by 2, and the y values are incrementing, but now start at height divided by 2 and go to the bottom of the canvas, which is height. Let y1 equal height divided by 2, y1 is less than or equal to height, y1 plus or equals 15. And then in here, we'll draw our line that will go from 0, y1 to width divided by 2, y1. Perfect. As you can see on the x-axis, the lines are going from the leftmost side of the canvas to the middle, and on the y-axis, they go from the center all the way down to the bottom of the canvas. Now let's do the last one. This one will be vertical lines, and that means that the x values are changing. They start at width divided by 2 and go to the right end of the canvas, which is width. The y values will stay the same, but the first point is now at height divided by 2, and they go down to the bottom of the canvas at height. So let's see that in code. For let x1 equal width divided by 2, x1 is less than or equal to width, x1 plus or equals 15. And then inside here, I'm going to draw my line which goes from x1 height divided by 2 to x1 height. Now let's run that and see if it works. That works perfectly. We can now customize the stroke weight if you want it to look more like the picture. Stroke weight. Let's try 5. Oh, that's a bit intense. Let's bring it down to maybe 3. Okay, that looks good. And there you go. Intro to For Loops challenge is done. Nested for loops are simply two for loops that can be used to create a grid structure for your elements. These for loops create multiple coordinates on both the x and y axes using very little code. The code inside the nested for loops will run a multiple of both the loops together. In this example, if the outer loop is run 5 times and the inner loop is run 6 times, then you'll get a total of 30 ellipses in your grid structure. Combining nested for loops and mapping is a very powerful technique that can be used to create really complex and interesting structures. Now that we've walked through conditionals and for loops together, it's now time to team up and give it a go. Get into groups of 2 or 3 and walk through the steps of the nested for loop challenge. And if you finish that challenge and are feeling super adventurous, then you and your team can try and create a gradient with the loops with color challenge. Just remember to bounce ideas and possible solutions off each other, and if you're stuck, then you can ask your tutor for help.